Lesson 13, Proving Lines Parallel. The objectives are to use the angles formed by a transversal to prove that two lines are parallel. If you remember, the converse of a theorem is found by switching the hypothesis and the conclusion around. Instead of P implies Q, we have Q implies P. Remember, the converse of a theorem is not automatically true, but if it is true, it needs to be stated as a postulate or proved as a separate theorem. Let's look at a postulate. 331, the converse of the corresponding angles postulate, and it states, if two coplanar lines are cut by a transversal so that a pair of corresponding angles are congruent, then the two lines are parallel. So we have lines M and N here, cut by this transversal, and we are given that angles 1 and 2 are congruent. Well, they're both above the line and to the right of the transversal, therefore they're corresponding angles. And since they are congruent, we know that the two lines are parallel. Let's use this postulate and the given information to show that L is parallel to M. Given that angle 4 is congruent to angle 8, we have angle 4 is congruent to 8. 4 and 8 are corresponding angles. So L is parallel to M by the converse of corresponding angles postulate. Let's look at another one. We can look and see that we have corresponding angles 3 and 7. And we're given that the measure of angle 3 equals 4x minus 80 degrees. The measure of angle 7 is 3x minus 50 degrees, and x equal 30. If we go ahead and substitute in 30 for our x, we get that the measure of angle 3 equals 40 degrees, and the measure of angle 7 is 40 degrees. That means their measures are equal to each other by the transitive property of equality. Since both equal 40, then they must be equal to each other. And that means that they're congruent angles by the definition of congruency. Therefore, L is parallel to M by the converse of corresponding angles postulate. Now you try. Pause the recording and try these two problems. We want to prove that C is parallel to D. So given that angle 2 is congruent to angle 4, we know that 2 and 4 are corresponding angles. They're both below the line that they're up against and on the right side of the transversal. Therefore, by the converse of the corresponding angles postulate, C is parallel to D. For the second one, we're given that the measure of angle 1 equals 2x, the measure of angle 3 is 3x minus 31, and x equals 31. So we plug in 31, and we work it out, and we get that the measure of angle 1 and the measure of angle 3 are both 62 degrees. So they are equal to each other and congruent to each other, and therefore C is parallel to D by the converse of corresponding angles postulate. The parallel postulate, 332, says that if we have a line and a point that is not on the line, there is exactly one line that can be drawn through that point to be parallel to the line we already have. This postulate guarantees that for any line, you can always construct a parallel line through a point that is not on the line in question. 3 more theorems that you need to add to your list are 333, the converse of the alternate interior angles theorem. This one says that if 2 coplanar lines are cut by a transversal so that a pair of alternate interior angles are congruent, then the lines are parallel. 334 states if 2 coplanar lines are cut by a transversal so a pair of alternate exterior angles are congruent, then the 2 lines are parallel. This is the converse of the alternate exterior angles theorem. And 335 says that if we have 2 lines cut by a transversal and a pair of same-side interior angles are supplementary, then the 2 lines are parallel. Let's use the given information and theorems to show that R is parallel to S. We're given that angle 4 is congruent to angle 8. If I look on my diagram, angles 4 and 8 are on opposite sides of the transversal, and they're also diagonally apart from each other on the outside of the lines. These are alternate exterior angles. Since they are congruent and they are alternate exterior angles, then R is parallel to S by the converse of alternate exterior angles theorem. Use the given information to show that R is parallel to S. In this case, we have angles 2 and 3. The measure of angle 2 is 10x plus 8 degrees. The measure of angle 3 is 25x minus 3, and x equals 5. If we substitute in 5 for x, we get that the measure of angle 2 is 58. The measure of angle 3 is 122. So the measure of angle 2 plus the measure of angle 3 equals 58 degrees plus 122 degrees, and that equals 180. Remember that if we have same side interior angles that are supplementary, we can use the converse of the same side interior angles theorem to prove that R is parallel to S. Let's look at another one. We're given that P is parallel to R and angle 1 is congruent to angle 3. We want to also prove that L and M are parallel. So, P is parallel to R because it's given. Angle 3 is congruent to angle 2. This is by the alternate exterior angles theorem. Angle 1 is congruent to angle 3, and that's given. Angle 1 is congruent to angle 2 by the transitive property of congruence. Therefore, L and M are parallel lines due to the converse of corresponding angles postulate. Let's look at a carpentry application. We have a carpenter and he's creating a woodwork pattern and wants 2 long pieces to be parallel. The measure of angle 1 equals 8x plus 20 degrees, and the measure of angle 2 equals 2x plus 10 degrees. If x equals 15, show that pieces A and B are parallel. So we are looking at these would be our lines that are cut by a transversal. These would be same side interior angles, If we can prove that they are supplementary, then we can prove that piece A and piece B are parallel. So a line through the center of the horizontal piece forms a transversal to pieces A and B. 1 and 2 are same-side interior angles. If they are supplementary, then the pieces A and B are parallel. So let's substitute 15 for x in each expression. The measure of angle 1 equals 8x plus 20. Substitute that 15 in, and we get 140. The measure of angle 2 equals 2x plus 10, and we'll substitute in the 15 for x, and we get 40. Angles 1 and 2 are supplementary since their measures equal 180 degrees. The same side interior angles are supplementary, so the pieces A and B are parallel by the converse of the same side interior angles theorem. Let's look at some problems. For exercises 3 through 5, use the theorems and the given information to show that J is parallel to K. So in number 3, we're given that angle 4 is congruent to angle 5. Well, these would be alternate interior angles. If they are congruent and they are alternate interior angles, then J is parallel to K by the converse of the alternate interior angles theorem. We're given measurements for angle 3 and 5 and that x equals 6. If we go ahead and substitute 6 in for x, we find that we have two angles, 3 and 5, which are interior same side, and they equal 180 degrees together. Since they are same side interior angles and they are supplementary, then J is parallel to K. And the last on this page, we are given that angle 2 and angle 7 have these measures and x equals 9. We'll again substitute 9 for x, and then we find out that they both are 72 degrees. 2 and 7, they're exterior angles. And if they're equal by the transitive property of equality, then they are congruent in the definition of congruent angles. And that means that by the converse of alternate exterior angles, J is parallel to K. So we have 3 different proofs to prove that the same two lines are parallel. For the next class, compare and contrast the methods used to prove lines parallel. The corresponding angles, the alternate interior angles, the alternate exterior angles, and the same side interior angles. Coming up next, we will have proving lines perpendicular, finding slopes and using them to prove lines parallel or perpendicular, and graphing and writing equations of lines. Have a good evening.